Hello, let's do some science. What is static electricity? It's a buildup of an imbalanced charge of protons, a positive charge, and electrons, a negative charge, caused by friction known as the triboelectric effect. When objects are rubbed together, a transfer, such as a gain or a loss, of electrons occurs. One object becomes positive and the other a negative. And because opposites attract, the hair stands up. But is there a way to determine or detect the transfer of the electrons? Well, let's find out. Well, in every experiment, there's a process known as the scientific method or the scientific inquiry. Today, we will focus on the scientific method. Starting the process, we must state the problem. In this case, what material produces the strongest static electricity? And through research, we can determine an educated guess or hypothesis and prediction. The hypothesis, more broad, the prediction, a little bit more. Now that we have finished the first 3 steps, it's time for the fun part, for the experiment. I have PVC pipe, a balloon, a piece of wood, a pencil, a piece of cardboard, and a pen. I also have a homemade electroscope, a ruler, and a washcloth. With every experiment, you must determine the variables. For example, the independent variable is a variable that changes throughout the experiment. In this case, it is the materials we'll be using to test for static electricity. Then we must determine the constants, or the variables that remain the same throughout the experiment to keep the experiment's validity. For example, we will use the same electroscope, the same ruler, and the same washcloth. And of course, we must set our dependent variable, which is the variable that we will measure, such as static electricity. But that leads me to our original question. How can we measure such a thing? Well, to measure static electricity, we will use an electroscope using copper wire, a plastic bottle, and some aluminum foil leaves. An electroscope detects the presence and magnitude of an electrical charge. When a charged object approaches or touches the electroscope, the redistribution of charges causes the needle or aluminum leaves to repel, meaning the more they repel, the greater the charge. But to measure just how much static electricity an object produces, we can then use the ruler to measure just how far the aluminum leaves repel. And then we could plot it onto our graph to collect data. Now on the graph, you'll notice that our independent variables, our materials, are on the x-axis, and our dependent variable, the static electricity, is on the y-axis. Now let's start with the PVC pipe. Now using the washcloth will create friction. As you can see, the PVC pipe produces 2 centimeters of static electricity. So marking 2 centimeters for the PVC pipe. Next, the balloon. Once again, creating the friction. The static electricity from the balloon shows roughly 3 centimeters. So marking 3 centimeters for the balloon. Now the wood. As you can see, the wood piece did not produce any static electricity at 0. Now the pencil. And once again, this shows that the pencil did not produce any static electricity. We will put this one at 0. Moving on to the piece of cardboard. And the cardboard also showed 0 centimeters of static electricity. So we'll put this one at 0. No movement from the aluminum leaves. Last but not least, the plastic pen. the plastic pen showed 1 centimeter of static electricity. So plotting that down. Completed our experiment, it's time to resort to our data. As you can see, the PVC pipe showed 2 centimeters, the balloon 3 centimeters, the wood, pencil, and cardboard all produced 0 centimeters of static electricity, and the pen produced 1. So, from the data shown, it's safe to say that the balloon holds and produces the most static electricity, therefore proving my hypothesis correct.